Imagine that we have a lot of small Lego bricks of two types, A and B. We want to connect them in pairs to get bricks of type AB. To do this, we need to take the same number of bricks of the two original types. If we know that bricks A and B weigh the same, then it is enough to weigh a certain number of bricks of type A and then take the same mass of bricks of type B. And we will not find ourselves in a situation where, after connecting the bricks, we will have an excess of one of the types. But what should we do if bricks of different types have different masses? What if each type B brick weighs 2 times more than the type A brick? I think you already guessed that type B bricks need to be taken 2 times more in mass. And then the number of bricks of both types will be the same. Obviously, if type B bricks weigh 3 times more than type A bricks, then they need to be taken 3 times more in mass, and so on. But how do we know exactly how much each type of brick weighs? For this, there is a special table where their masses are indicated. A very important fact to remember: bricks of all kinds are made up of the same elements. Let's call these elements, as they are called in chemistry, nucleons. The lightest type of bricks consists of 1 nucleon and therefore has a conditional mass of 1. Let's assign number 1 to this type of bricks. The second type of bricks consists of 4 nucleons and therefore has a mass of 4. The third kind of bricks consists of 7 nucleons and has a mass of 7, and so on. The mass of each type of brick, indicated in the table, is equal to the number of nucleons of which it consists. Therefore, if we want to take the same number of bricks number 2 and number 3, we should take 4 mass units of bricks number 2 and 7 mass units of bricks number 3. What mass units are we talking about? It doesn't matter. You can take 4 and 7 grams respectively. You can take 4 and 7 pounds respectively. Or even 4,000 tons and 7,000 tons. The main thing is to keep the mass ratio 4 to 7. Then the number of bricks of these two types will be the same. The bricks we're talking about are very, very small. 1 gram of the lightest bricks contains approximately 6 times 10 to the power of 23 pieces. This quantity is called Avogadro's number. If we take the same number of bricks number 2, it is clear that they will weigh 4 grams, since each brick number 2 is 4 times heavier than brick number 1. 7 grams of bricks number 3 will also contain 6 by 10 to the power of 23 pieces, and so on. 6 by 10 to the power of 23 bricks of any kind is called 1 mole. A mole is simply a huge number used to count large quantities of something. A simple analogy: the distance from the Earth to the stars can be expressed in kilometers. For example, from the Earth to the star Alpha Centauri C is about 4 by 10 to the power of 13 kilometers. It is a huge figure that is difficult to comprehend and difficult to handle. But if we take as a standard the distance that light travels in 1 year, it turns out that this star is 4.2 light-years away. This figure is already much easier to deal with. And if we are told that the distance from the Earth to a certain place in the galaxy is 13 light-years, then we immediately understand that this is about 3 times farther than to Alpha Centauri C. In chemistry, 1 mole is chosen as the standard for the amount of a substance. This is much more convenient than using the number 6 by 10 to the power of 23 in every calculation. The mass of 1 mole of atoms number 1, hydrogen, is equal to 1 gram. The mass of 1 mole of atoms number 2, helium, is 4 grams. The mass of 1 mole of atoms number 3, lithium, is 7 grams. And in order to find out how much 1 mole of atoms number N weighs, you need to find in the table the relative mass of this type of atoms. This knowledge will help us calculate the amount of a substance in moles if its mass is known. For example, 21 grams of lithium is how many moles? 1 mole of lithium weighs 7 grams, 21 grams is 3 times 7. Therefore, 21 grams of lithium is 3 moles, that is, 3 times 6 by 10 to the power of 23 lithium atoms. Of course, we can solve problems in the opposite direction. How much lithium do you need to take to get 5 moles? Well, since 1 mole of lithium weighs 7 grams, then to find out the mass of 5 moles, you just need to multiply 7 by 5. Answer: 35 grams of lithium is 5 moles. Some chemical elements are gases, so they are not weighed, but measured by volume. 1 mole of any gas under normal conditions occupies a volume of about 22.4 liters. Therefore, to get 2 moles of helium, we need to multiply 22.4 by 2. That is, 44.8 liters of helium is 2 moles. Hydrogen exists in nature in the form of diatomic H2 molecules. Therefore, if you take 22.4 liters of hydrogen gas, it will be 1 mole of molecular hydrogen. But there will be twice as many atoms in this gas. In order to find out how much 1 mole of a substance consisting of molecules weighs, it is necessary to add the atomic mass units of all the atoms that make up the molecules of this substance. For example, a water molecule is made up of 1 oxygen atom and 2 hydrogen atoms. We look at the mass of an oxygen atom in the periodic table of the elements. It is 16. We already know the mass of hydrogen atoms. It is 1. Therefore, the mass of a water molecule is 16 plus 1 equals 18 units. Conclusion. 1 mole of water weighs 18 grams. Or, in other words, to take 1 mole of water, you need to weigh 18 grams of water.